Hi students, this is day one of simplifying trig expressions using identities. And we'll get to that in just a second. I wanted to review how to simplify some important things that we're going to come across. Um, if you are trying to add two fractions, like in example one, you have to have a common denominator. One way to find a common denominator is to multiply your two denominators together. So if we multiply the denominator by y, we have to multiply the numerator by y. So that would give us y squared. If we multiplied the denominator by x, we have to multiply our numerator by x, and that would give us x squared. Now that we have that common denominator, we can add our numerators together. Another example I wanted to show you, in example 2, is just to remind you that you cannot cancel out these x's. You cannot cancel if you're adding or subtracting, only if you are multiplying. So this is simplified. There's nothing you can do. In example 3, I wanted to talk about having a binomial over a monomial. When you have a binomial over a monomial, you can rewrite in two separate fractions because x and y share the common denominator. They share the common denominator xy. You can write this in two separate fractions, reduce because you're multiplying. We'd have 1 over y plus 1 over x. Okay, I just kind of wanted to remind you of those properties. Now let's get into the real notes of the day. Let's talk about the reciprocal identities, which say that when cosecant is in the top of a fraction, it is equal to having sign in the bottom of a fraction. This is a reciprocal identity. Identity means that they're equal. They're identical to each other. They may look different, but they are equal to each other. And vice versa. If cosecant is in the bottom of a fraction, it's equal to having sign in the top of the fraction. And same thing with secant and cosecant and cosine. When cosine's in the bottom, it's equal to having secant in top. If secant's in the bottom of a fraction, that's equal to having cosine in the top. And same thing with tangent and cotangent. If tangent's in the bottom of a fraction, that's equal to having cotangent in the top. If cotangent's in the bottom, that's equal to having tangent in the top. So you might be thinking, how are we going to use these? So what if I had cosecant theta over secant theta? Okay, if I wanted to or I needed to, I could rewrite these using sine and cosine. If cosecant is in the top of the fraction, that is equal to having sine in the bottom of a fraction. If secant is in the bottom of the fraction, that is equal to having cosine in the top of the fraction. And we could rewrite this in terms of sine and cosine instead of secant, cosecant. We get down to the next type of identity. We call these the tangent and cotangent identities. Tangent is equal to sine over cosine, and cotangent, which is tangent's reciprocal, is equal to cosine over sine. Okay, the next type of identity these are called the Pythagorean identities. This one says sine squared plus cosine squared equals 1. So you're going to memorize these. If you're in pre-AP, if you're in level, you're going to have a formula sheet. So sine squared plus cosine squared equals 1. So let's look at that one down here. I could solve that for sine squared if I were to subtract cosine squared from both sides. So I subtract cosine squared theta from both sides, and it would say sine squared theta is equal to 1 minus cosine squared theta. I could also take the same original equation, and I could solve the original equation for cosine squared if I were to subtract sine squared theta from both sides. And my new equation would say cosine squared theta is equal to 1 minus sine squared theta. And likewise with the second identity, we could take tangent squared and solve it for tangent squared. So we subtract 1 from both sides. Tangent squared theta is equal to secant squared theta minus 1. And same thing, what would 1 equal? Well, I would have to subtract tangent squared from both sides. So subtract tangent squared from both sides, and I'd have 1 is equal to secant squared theta minus tangent squared theta. Okay, and this would equal 1 right there. I could take the last one and I could do the same thing. I'm just going to tell you what it is. The second one, 1 would equal cosecant squared theta minus cotangent squared theta. Okay, so let's move on and let's see how we're going to use these. All right, move down here. In example 1, it says if tangent theta equals 4, which is really 4 over 1, what is cotangent theta? Cotangent is tangent's reciprocal, so 1 over 4. Let's just do example 3. If cosine A equals 3/5 and they want us to find the sine of A, we're going to use our Pythagorean identity, the first one in the Pythagorean identities, where it says cosine squared plus sine squared equals 1. If you know cosine is 3/5, we'd have 3/5 squared plus sine squared equals 1. 3/5 squared is 9/25. We have 9/25 plus sine squared equals, I changed 1 into 25/25. We're going to subtract 9/25 from both sides. Subtract 9/25. And we have sine squared A is equal to 16/25. We take the square root, and we always put plus minus in front of a square root sign. So we have sine A equals plus minus, square root of 16 is 4, square root of 25 is 5. All right, let's keep moving. There are 10 examples, so I'm going to try to get through most of them. So we have sine theta, and I'm going to make that sine theta over 1 times cosecant theta. Cosecant is sine's reciprocal, so it's equal to 1 over sine theta. Cosecant, if you look up above, cosecant theta is equal to 1 over sine theta. So these cancel, or they give you sine over sine. Either way, you're going to get 1. So long story short, if you multiply reciprocal functions together, you multiply reciprocals, you will always get 1. You multiply tangent times cotangent, you get 1. If you multiply sine times cosecant, you get 1. In example 6, we've got cosine y over cosecant y. We're going to try to always think about writing things in terms of sine or cosine. So I like this one, cosine y. I'm going to make it over 1 times cosecant. I'm going to change that one out. I know from up above, cosecant is equal to 1 over sine y. So we multiply fractions straight across the top, straight across the bottom. So we end up with cosine y over sine y. And cosine over sine, if you look up above, cosine over sine is cotangent. So that would be our final answer. We always try not to leave fractions. So we always want to try to leave answers that do not have fractions in them. Example 7, to me, that is a vertically written division problem. It really says tangent A divided by sine A. So I wrote it horizontally, and then I'm going to trade out tangent A for sine A over cosine A. Dividing by sine A over 1 is the same as multiplying by 1 over sine A. Remember, dividing is the same as multiplying by the reciprocal. My sines cancel, sine A cancels. I end up with 1 over cosine A. Cosine's reciprocal is secant. So my final answer is secant A. We try never to leave a fraction whenever possible. Example number 8. In example number 8, I see we have a binomial. Binomials are made up of two terms separated by either a plus sign or by a minus sign. And in this problem, I noticed that the two terms have sine squared in common. So I'm going to factor out the sine squared. I would have 1 plus tangent squared. I know that 1 plus tangent squared is secant squared. So now I'm down to sine squared times secant squared. I'm going to always try to rewrite things in terms of sine and cosine. So secant squared is 1 over cosine squared. I multiply straight across the top, straight across the bottom. I end up sine squared x over cosine squared x. I don't like to leave fractions. I know that sine over cosine is tangent from above, so sine squared over cosine squared will be tangent squared, and that's that. Okay, number 9. Number 9 is an easy one. The first part of it, we have that sine squared plus cosine squared. If you look up above, that is equal to 1. So we have 1 over cosine squared x. And if we change that, because we don't want to leave a fraction, if at all possible, don't leave a fraction. So 1 over cosine is secant. So 1 over cosine squared is secant squared x. Okay, last problem. These are called conjugates. Conjugates are where the only difference is the sign that comes in the middle. So these are called conjugates of each other. We're going to FOIL this, but you're going to notice when we multiply these together, something will happen. So we take 1 times 1, that's first times first. The outside times the outside, that gives us negative cosine x. The inside times the inside, that gives us positive cosine x. And the last times the last, that gives us negative cosine squared x. We're going to notice when we multiply conjugates together, the outside inside cancel out. So really, truly, all you need to ever multiply together is the first times the first and the last times the last. And if you look at your identities, 1 minus cosine squared is sine squared x. So we always are trying to simplify to the simplest form. I hope this is helpful to you guys. We made it through the notes before our 15 minutes is up. There is a worksheet called Day 1 worksheet, Simplifying Trig Expressions, Day 1. Have a great day, guys. Bye.